Hey everybody, this is Larry. This is day 12 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this particular problem. No updates today, just ran a couple of miles, like 5 or 6 miles or something. But yeah, still my body's very tired, even though they're easy miles. After yesterday's half marathon, not even, I don't know. We'll see, it's very exciting. Or like, at least I'm very excited. There's like a fire right in front of me, so yeah, probably can't see it. But anyway, yeah, let's take a look at this problem. Let's go and go Yankees and go Liberty. 2406, divide intervals into minimum number of groups. Okay, so you have 2D integer array intervals. You have an inclusive bounds. Okay, you have to divide integer into one or more groups such that each interval is in exactly one group and no intervals are in the same group intersecting each other. Return the minimum number of groups you need to make. Two intersect if there's one number. Okay, fine. So then now you have... Okay. I was gonna... I guess the part I skipped was the part that I was looking for. This is what happens when you suck at reading. But yeah, okay, so they intersect. Okay. This problem is relatively, so I think the hardest part about these problems, right, is proving greedy, right? There is some sort of greedy type thing and you're trying to basically prove it. N is 10 to the 5th, so it could be big. The idea here is that how do I structure the idea, right? So basically, first of all, you want to sort by the beginning, the beginning of the interval, and then you do a sweep line, right? And right now, I'm actually setting up for the drawing things and putting up on the screen, of course. Try to find my pen. The idea here is kind of think about try to think about how to, or like what are the invariants that you get as you do a sweep, right? And in this case there are loop invariants possibly, but just the idea of like what happens when you have invariants, right? Or like what these invariants are. And wait, is that not drawing? Okay, it is drawing, but I don't know why I didn't click last time. Okay, so you have all these intervals, right? And they're on some timeline. And you know, let's just say they're sorted, you know, for now, you know, something like this, right? And you have a lot of intervals. And then, you know, let's say you also are able to process everything to the left, right? So maybe like, let's say you're here right now, because everything is already sorted. You already processed the endpoints of here, right? And I kind of, actually, and this is common, but you already processed these because you processed by the beginning point. So then now the question is, okay, so you have this, oops. I guess I drew off the screen. But now you have more intervals coming, right? What do they mean? Well, in this case, we kind of just think about the visualization, right? Well, and this is, so that if you sweep, yeah, maybe you sweep, well, let me, you know, maybe you sweep this line going to here and then after that, and, you know, without loss of generality, that's the thing. And then now you process the beginning endpoint of this thing. And then the question is, okay, well, what are the invariants, right? Or what are the observations even before invariants? Well, the observation that I would make here is that, I guess I drew a kind of a bad example because there's no overlapping cases, because you can also imagine like this one have one here and these are like two different groups or something. But the thing is that it doesn't even matter, right? Because we know that the endpoint is to the right. The endpoint is yeah, over there, right? So what does that mean? That means that everything to the left of this line, it really doesn't matter what you pick, right? Or I guess this line. I guess if we're going to do a full update, technically it's left of this line, because we process this from left to right, and then now this second line to the right. And we're still focusing on this interval, right? Well, everything to the left almost doesn't matter which one you do it, right? And what I mean by that is that, let's say you have this interval and you want to insert it into this group, or this group, or this group, like all these groups that ended before the line, it doesn't matter which one you go because the gap doesn't matter, right? For this problem, the gap here, it doesn't really matter what it is. All you know is that you're able to fit in a group, and you need to put in a group anyway. And the only choice, and now that we have established that all the groups are the same, given that they're free, now that we established that they're all the same, then there are only two decisions, right? Whether you use one that you should, or you start a new one. And even that, and I'm saying that, and maybe I'm not really precise on that language, but even that, right, it's not necessarily true, because maybe that's not a decision, and that's where the greedy part comes in. And the greedy part comes in because then now the argument is that you always want to use an old one because there's no reason to use a new one, because using a new one will not give you a better result later on. It will give you the same result or worse. So that's basically, and you could prove that by, I think case analysis is good enough for that. And by case analysis, I just mean like go over every case. So yeah. I will also say one more thing though, is that after I drew it out and kind of talk about it through, I mean, initially I didn't really talk about it that way, but after I, talk it out and thinking about it through a little bit, and talking to y'all at home, I can see why this is related to yesterday's problem, the max problem, the minimal excluding problem. Because then now, if you think about it, and maybe I should bring it back up for just a second, hang on. If you think about it, then now, because all these are the same, then you only really have to figure out, okay, well, if this is chair 1, chair 2, chair 3, chair 4, and then now you have some endpoints where that chair is free again. And I say chair if you didn't watch the video from yesterday, because that is the problem yesterday. We have these things with chairs, right? So that's basically really the idea. And from that we can probably do everything. So yeah, so first we want to sort by the interval, right? Because then now we want the beginning point, and the end point is when that chair becomes free. Right? And in fact, I think now, after you sort it, this is exactly the same problem as yesterday, right? I think I didn't do a great job with how I talked about it yesterday, because I was just so tired, honestly, so that's my fault. But yeah, that's the minimum or minimal excluding things you can Google. But basically, that's pretty much it, because we have all these intervals. I mean, of course, we're targeting more than one friend, and we're asking a different question, which is how many chairs are there, or how many chairs do we end up using? And that's really the thing, right? And there are a couple of ways you can kind of bound it. I mean, if you're lazy, you could do, or like in terms of what I was talking about yesterday, you can do it this way with a heap, right? And maybe we could do it. I don't know. So yeah, so maybe we have a max answer. So max groups is equal to, or maybe just groups even, right? Groups is equal to 0. We have yesterday I was a little bit lazy, and if you kind of look at the code, I talked about how I said I'm lazy, but it's really confusing. Because there is a way to load this in a lazy way, such that you don't need to load all n, right? And in a similar way, you can imagine us today, we can do this where n is the number of intervals, and that would be fine. And then you can actually just copy and paste this entire thing, right? Okay, actually, let me just do that. We'll up-solve it later, but I just want to, as a proof of concept, I want to show you that this can work. And this is intervals instead. Except for that, in this problem, there is one change, which is the 5s intersect. So that means that we actually want to prioritize the starting one after the thing, right? It's a very subtle change. I'm not going to talk about it too much, but that's the idea. And here, we can for this answer, we were trying to do the max groups, right? So groups we can just do whenever we pop a chair, we can, there's no target friend, but if chair is greater than groups, then groups is equal to chair, and that's really it. But we'll upsolve it. Hang on. But I just want. Ooh, I forget. I do want to upsolve it, but I just want to talk about how they're equivalent. I mean, 0 is a really bad answer, so. Maybe I copy and paste. Alright, let me actually take a look real quick. N with n people, so it has to be at most n, okay. Enumerate the intervals with the index. We don't even care about the index, I don't. Okay, I mean we do because of this thing, but oh. Why does this compile? Where are we getting times from? Why? How? Am I? Like, I mean, I expect, like, we have to fix this, but I'm just getting like, why does it not, like, am I? Oh, because times is a keyword in Python, right? Maybe. Huh? Like if I replace this with just like, I don't know, ABC. What? Is Leetcode doing something silly? Like, I know this is wrong and we can change this to intervals, but like, okay, maybe not, maybe I lied. Do I ever return 0 somewhere? Or maybe this just never get caught? Is Leetcode being silly, or am I just like am I being silly? Like why, like this code did not execute at all, right? And this should execute no matter what, right? Print H, does that do anything? Hopefully. No, that works. So, I guess the only reason why this didn't trigger a thing is because this loop never happens, but I don't know why it never happens. Defense is clearly length of defense is greater than 0. Oh, I am dumb. Okay, I am dumb. That is my fault. Some days you just, because I changed the type to change the sorting order, but I didn't change the type here. This is why you use this is why you use enums, honestly. Okay, so I think now we should be good. I mean, we this is 0 index and this is 1 index, but we should be good. And if I had left it like this, it would have been, yeah, that's what I expect. That's why I was like so confused as to why we get zeros instead. But this is what happens when you have an interpreted language. But yeah, that's pretty much it, I think, right? So we could, let me YOLO submit. Maybe I made a mistake, but it should be okay, yeah. Yeah, so we used 2 heaps for this for yesterday's. And as I said, this is very, yeah. You don't need all n though to get the answer. You can do this in a lazy way. So here, maybe we just start like this, right? So then now, we go, yeah, so if length of h is 0, that means that we cannot pop a chair. Then now we can say heap q. This actually wasn't that hard. I don't know why I didn't think. I know why I didn't do it yesterday, because I was just too tired. But groups, right? And then groups increment by 1, and then we don't even need this anymore, right? So we can run it again. Yeah, now we don't need the +1 because we incremented after using it, right? So yeah, this should be I thought it would be a little bit more faster, honestly, but you can see that this will be faster because we only push when necessary, but it's only slightly faster. But yeah, and I mean, I guess another way that the thing that we talked about yesterday is that we can do this thing here. Yeah, we can keep track of this in the same time, right? So then we can do this. We can do the ending time. And then we keep track of the index, and the thing is that then now we just keep track of the chairs, right? So chairs is equal to none times n, right? So then now we can do it this way, and the way that you think about it is that, yeah, it's exactly like this. And yeah, chair sub index is equal to this, and when we pop, we push the well, this was the index yesterday because we used the third parameter as the chair, but we actually want to push back chair sub index, right? So that's one more optimization that you can do. Actually, technically, I don't think this is an optimization yet. I think this actually makes it worse. But this is a refactoring that you can do, right? Is okay. I mean, it may be slightly faster, but because you get rid of an if statement or something like that. But yeah. But then now you put in here. But then now another optimization that you can see is that well, we push all these, so then this is equivalent to just sorting, right? So then now you can do append s-1 index events dot append y1 index, right? And then events start sort. Oops. So this will be faster because that's just the way it is, I suppose. I guess you could also maybe use heapify, but oh no, how does this even? Maybe I mean I messed up on this for sure because I sort this and then it's a sort. I guess a sorted array is in its nature a heap, but because the top element is always going to be bigger than the child, but that's a funny mistake actually, and I honestly never considered it, so that's kind of funny actually. At least that's it for me. But yeah, then now you can write it this way because before it wasn't optimized. But then now you take advantage of the fact that sorting is much faster, right? So yeah, so that's really the idea. And I think one thing that I would say is that this is a time to point out is that this is why I always say, you know, practice so that you can spend time either on your interviews or on the contests and stuff like this. Practice so that those things become easy, right? Your actual goal, the things that you actually care about, becomes easy. Because as you can see, I'm just like, oh wait, this is that same problem. I mean, of course, you know, it will always be the same problem as you did yesterday. So it may take some time to find the code and then copy and paste it in or whatever. But you don't even have to copy and paste. It's just having that idea already, and you're like, oh wait, this is just this thing, and then you just, you know, dump it in. And if I didn't do it yesterday, I might not have. Like I would have solved it in another way, obviously, but yeah, it's just the same idea. Anyway, yeah, that is all I have for this one. Let me know what you think. Yeah, let me take a peek at the solution. Sorting a priority queue, line sweep of an order container. Okay, I mean these are just like extra words with no. Wait, do they always give to you in sorted conditions or something? How is there like an O of N situation? I didn't go with complexity yet, I think, but it's not going to be that interesting. It's the same as yesterday. This is sorting, and log n, and log n. That's it, right? I mean, it's very yeah, n log n, or of n loop, or of log n per loop. So, you know, n log n is pretty much. But I'm trying to figure out like how do they. How do they do the non-sorting and log n? Okay, range start and range end. We are getting iterate over the intervals to mark the points to the list, points to count. Oh, I see. So basically you're doing 1K at a time. I mean, K is kind of... K is basically the range of the numbers, which I guess you can take advantage of. So that's why you're not sorting, and that's why you are able to do it. Or range of numbers is actually 10 to the 6. But I don't know. That's a wonky answer, if you ask me. But I mean, maybe it's useful for certain things. But yeah. Anyway, yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Actually, let me take a quick look to see how Larry from last or 2 years ago did. Well, Larry from 2 years ago did it. This is much cleaner. Oh, this is what. Well, this is actually the way that the one that I was confused a little bit about because of this complexity, right? So this is actually this solution, except for that I sorted the keys instead of going from 0 to 10 to the 6. I go from 0 to, well, their solution is going from 0 to 10 to the 6. Mine is just, okay, well, we have all these unique numbers. I just sort them and then go up. So that's basically the idea, to get the maximal thing. But and that's fine. I think this is kind of cool. Yeah, I mean, I wrote more code this time, but you saw that it was because I did it yesterday, right? And I kind of relate the problems. And you know, there are multiple solutions for the same problem, which is kind of good, right? Like, I don't know, if you're only able to solve it with one way, then certain other problems will make it a little bit tougher on you. Anyway, that is all I have for this one, though. Let me know what you think. Thanks for watching. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.